Hello, I've got a bit of a habit of going to car boot sales at 6 o'clock on Sunday mornings. Occasionally I find interesting electrical things to bring home and dismantle, but very rarely, like once in a lifetime, I find something like this. Now, this is the E&MM Spectrum synthesizer from 1981. This little copy of the magazine. The E&MM stands for Electronics and Music magazine. This is one of the cover projects of the March 1981 launch issue of the magazine. It was designed by Chris Jordan, who was the magazine's technical editor at the time. Now, this synthesizer was never available for purchase as a complete working factory-built synthesizer. It was a project in the magazine that you had to build yourself, a DIY synth. Maplin's Electronics had a bag full of parts complete with the etched circuit boards and everything, but this did not include the CEM chips which were required to complete the synth. Those you bought separately from Digisound Limited, which was a UK company set up by Charles Blakey in the 1970s. Charles Blakey designed many synthesizer modules which appeared in several magazines during the 70s and the 80s. The metal silkscreen faceplate was £14.95 and the joystick mounting plate was another £1.80, but I think that all came in the kit from Maplin's, which cost £167.50, including VAT of course. The wooden cabinet was down to you. There was no pre-cut parts available, just the plans in the magazine of the sizes and how to construct it once you cut all the pieces yourself. This one looks reasonably well built, but I'm not sure how many kits were actually sold or how many of the synths were completed and actually worked. I've never heard of these, I've never seen one of these until this one turned up. So even though this one sounds pretty terrible, there's definitely something wrong with it. Let's open it up and investigate. So, screwdriver time. Actually, before I take it apart, let's have a quick listen to it. Now, I've fired it all up, it's coming through the amplifier, but there's not it's certainly crusty, that's for sure. Whether it's 33 years of crap and things that's built up underneath this, I don't know. It's in reasonably good condition, really, looking at it, but that's about the most musical sound that I've gotten out of this thing. So yeah, we definitely need to take this apart and investigate what the hell is wrong with it. I've tried everything in all sorts of combinations. I'm no stranger to synthesizers, but that is, there you go, now it's almost gone. So let's get in it and see if we can make this do something. This has got 5 jacks on it, and yet in the instruction manual there's only 3 jacks, so I'm kind of wondering what the other 2 are for. I'm sure we're going to find out when we get in here, see what sort of job somebody's done. Oh, it looks quite nice. Oh, it looks reasonably neat. Apart from the spaghetti wiring there, all the circuit boards look very professionally done. Well, here's a little look behind all the pots and multi-turn switches in there. Yeah, it looks a little bit of a rat's nest, but you know, it's reasonably neat. And then these are all your CV gates and key CVs and things there, so you've got a little bit of control to go in and out of this keyboard. And underneath there is the joystick controls, and here's the keyboard, and luckily the keyboard seems to be hinged, so if I take this off then I should be able to hinge up the keyboard and have a look underneath there. But basically in here what I'm going to have to do first is just check all the wiring and make sure, you know, there's no wires come off anywhere, because it doesn't sound very good. So that's the next job. I'm going to flip it around and take that panel off there and lift the keyboard up and have a look at that. After a lot of battling, I've managed to get the keyboard up at least, there's nuts and bolts underneath here. The guy who built it must have had long nosed pliers to get the bolts in and things. So yeah, it's a bit of a pain, but I've got it up. Unfortunately, there's little metal springs on here, and the little metal springs sort of go down and they touch a contact. Now, at the end of the springs, they've been glued into little posts which are attached to each key. So I can't lift off the keys to try and clean underneath here. Right, I've got no choice but to try my very best to lift this board off. So I've unscrewed all these little bolts, and I'm going to try and lift these so I can clean the contacts underneath. It's interesting, these old keyboards, they are just resistors on the bottom of each key, and they're 47 ohm resistors, so the signal comes in, goes through a resistor, and then back out through one of the bus bars which are underneath here. So what happens is, further up the keys, it's adding more and more resistors, therefore reducing the amount of power going back. So the lower the signal, the higher the note. I've sort of worked out it's about 0.3 of a volt each key. Anyway, the modern keyboards are lots of diodes in a sort of a matrix, but this, just a row of resistors, nice and simple. Right, let's try and get this thing off. I've got this all unbolted, and as you can see, as long as I'm being nice and careful, I don't want to stretch those springs any more than necessary. There's all the little springs. These springs lay across these two bus bars that run the entire length of the keys, and it's really quite dirty. 30 or more years of crap that's built up on there. So I'm going to give these a good clean all the way along, these two bus bars, and try and sort of clean some of these springs up as well. I mean, just scratching there, it's making it a little bit shinier already. But I'm going to find some cleaner now, and for the next hour try and clean all these springs up and all these bus bars. Right, to clean these little bus bars here, I found this tool with a tiny groove in the end, and I'm not sure if these bus bars are silver coated, which is probably why they've gone black. But if you just nice and gently, not too much pressure, because if it is silver coated I don't want to bite through that, but if we just go up and down the bar with that little groove, then as you can see it's only surface crap. And you only need the top layer anyway, because the top bit is where the little spring contact actually touches. So right, the next job is trying to clean up these little spring contacts. Now this is just a standard switch cleaning solution. I'm putting a little bit on each one and just giving it a rub with the cotton bud, and that's just enough to get some of the crap off there. See? Easy peasy. The only problem is there's 48 of these to go, so I'll get back to you. Right, that's all nicely cleaned up now. I've cleaned all the springs and all the bus bars, and I've given them all a little coating of switch cleaner as well to try and stop the oxidization. I don't know if that's going to work, but that's not bad for 30 something years. It might last another 30 years, who knows. Oh, I could eat this stuff, it smells so nice. I thought whilst I've got it all in pieces, I might as well give it a good clean up, just in case I get it working. I've cleaned all the keys up, looks like a nice new keyboard now. I used this amber cleanse for that. It's very good. It's sort of a foaming cleaner. It's very good for plastics and keys and things. I've had that one about 10 years, so they last a long time. But this is good old wood polish. Oh, it smells wonderful. Now what I've got to do as well is this keyboard, I'm going to use a bit of this rainbow ribbon and then put in a new cable from the keyboard to the electronics at the back. because that one's a little bit short. When you take the back off, it's pulling at the wire because the wire is so short. So I'm going to add 2 or 3 inches onto this and make a slightly longer connection for it. This chip is certainly sitting too high up out of its little holder. I mean, it's probably still connected everywhere, but we'll just shove that down flat. The keyboard's in, the keyboard's been cleaned up and it's all back together, so I'm going to flip it around, power it up and see what sort of sound we get out of it now. I've cleaned up all the keys and the potentiometers. A lot of the switches were quite crusty, but then it's over 30 years old. Now I'm going to go through the different boards on here, basically what they do or what they're supposed to do. I'm still not happy with the sound that I'm getting out of this. Now on the power supply is quite important for a synthesizer because this, you know, when I've switched it on, it tends to drift. Even though I've had it on for an hour, it's still drifting around, so I want to, you know, start again from scratch basically. Now the power supply is supposed to be -15, 0, +15. What I'm actually getting out of it is -14 and +14.2 or somewhere around there. So I'm going to explain how the power supply works and we'll set that so it's exactly 15 and -15. The first board here is the power supply. Now this is supposed to be +15 and -15 DC. Here is the transformer. That's giving about 21 volts AC on the plus and the minus. Then the power runs through the protection fuses and then down to the 4 diode rectifiers and then off to these capacitors, which are just used for reserve. Now the chips in use are the UA723s. They're precision voltage regulator chips, and when they're used in conjunction with this power transistor, that should limit the current to about 270 milliamps. When the voltage across this resistor reaches 0.6 volts, and that diode is just to protect the polarity. Now, I've just tested this a minute ago, and it's not really ±15 volts, so power the thing up. Now the plus side is 13.9 volts, so as this is the only pot on the board for this side of the power supply, obviously this is what we're going to adjust it with. So I'll go up and try and get it as near to 15 volts. Down a little. There's hardly any movement in this. There you go, 15.03, that's close enough. Now on the negative side, 14.4. Let's try and get that to 15. A little bit more. Yeah, I'd say 15. -15.001. I'm not going to get any closer than that. So right, that's the power supply board set up, and now we've got a reasonably equal voltage plus and minus going into the rest of the synthesizer. Now the next board is the keyboard control. What happens here is a voltage goes out to the row of keys, and each of the keys has a 47 ohm resistor across 48 keys. Now when that voltage comes back after it's gone through the ladder of resistors, it comes into the sample and hold circuit, which is this part. Now middle C should be 3.7 volts on this keyboard, and then every C upwards goes down a volt and every C downwards goes up a volt. And this little pot here is what you use to adjust the 1 volt per octave. However, I can't adjust it because it's wavering all over the place. This is what's coming back from the sample and hold. So if I press middle C, we should have 3.7 volts. 3.7 volts, but already it's dropping. If I turn the tone up, as the voltage drops, the tone increases. Now if I press the next one up, it should be 2.7 volts. 2.6, and it's falling. So I'm not really sure what's going off there, but I think maybe the capacitors in the sample and hold, which is these poly layer capacitors, either that needs changing or maybe some of the other capacitors. So I'm going to unscrew this board, take it apart and do a few little tests underneath, and I might just change the capacitors anyway because they're 30 odd years old. On the back of the board, for some strange reason, I've noticed that there's super glue, or looks like super glue, along some of the tracks, and there's a bit that's underneath the capacitor. So I'm going to pull that capacitor out and replace it with another one and then test the capacitor. So that's for the sample and hold, and that should stop the thing drifting, hopefully. Right, here's the little poly layer capacitor, and it's a 0.47 microfarad, so that's 470 nanofarads. Because the microfarad symbol is to the left there, that's where you put the point, so that's 0.47. So I'll just test this. Open circuit or low capacitance. It's probably because it's a low capacitor that it's not reading this, so let's put it on something else. 0.475. Well, the capacitance is correct, but you know, that doesn't read ESR or anything, so I'm going to change it anyway. On the left is the old capacitor, and I'm going to replace it with one of these. It looks a little bit different, but it'll do the same job. Okay, with the new capacitor in here, it seems to be a lot more steadier. It's still a little bit out, and now we've got to use this little trimmer pot, and as we adjust it, keep on pressing the key, because the key is re-triggering the sample and hold circuit. So I'm just turning it a little and then re-triggering the key to try and get it to 3.7 volts, or as close as possible anyway. So 3.7001. So that's better, and now the tone holds much nicer. Now this board is the LFO, which is the low frequency oscillator. In a synth, it provides waveforms for the control of other modules to produce modulation of pitch, timbre, amplitude, etc. The LFO must have a wide range of frequency and a choice of waveforms. This LFO has a range of 0.04 Hz, which is 25 seconds per cycle, to about 42 Hz. And there's sine wave, triangle, ramp, square, and a couple of other step type waveforms, one of them being a random voltage. There's only one adjuster on here, and I'll be coming back to that later when I set the entire synthesizer up. Now this big board in the centre here is the VCO board, which is the voltage controlled oscillator. This can be the most expensive section of a synthesizer and will require a heck of a lot of setting up, hence all the pots everywhere. But I'm going to come back to that towards the end of it because there's a particular order in setting this synthesizer up. Now this uses two CEM3340 Curtis chips, which are self-contained VCO chips, and they feature both exponential and linear control scales and up to 4 buffered output waveforms, being triangle, sawtooth, square, and one of them in particular a variable pulse width. And they've got the full temperature compensation and everything in there. These are getting really hard to find. I've just had a look on eBay, and these go between £20 to £40. Fortunately, I know these two work. Now this board is the filter board, and on here there's another CEM chip, the 3320, which is a VCF chip. This has got 4 identical filter elements controlled by a temperature compensated exponential converter. Now each element in this contains a transconductance type amplifier plus a buffer amplifier to avoid loading of the TCA's output. The 4 sections can be interconnected to provide filter responses like low pass, high pass, band pass and all pass. And in this circuit, the filter can be made to oscillate and act as a third VCO. Now, the last board, this is the envelope shaper. Again, this is using CEM chips. They are 3310s, and those are envelope shapers, voltage controlled envelope generators rather. These are basically your ADSR in a chip, and there's 2 circuits on there, one of them slightly different. I think this is an inverter on this one, so it'll provide EG plus and EG minus signals. There's a bit of circuitry here for key repeat, and there's another CEM chip there, which is a CEM 3330. That's a dual voltage controlled amplifier. I'm not quite sure what this is doing at the moment, but I'm sure I'll figure it out later. Anyway, this synthesizer sounds pretty bad, and I think it's just going to be a case of getting it set up now. So back to the instructions, and I'm going to go through the instructions and set it all up, get the oscilloscope out, and hopefully we'll get to hear what this thing was originally intended to do. Right, I've flipped the keyboard around now, this synthesizer, and I've balanced the circuit board up here so that I can get to all the pots and things, and now I'm going to get the instruction manual and go through all the setting up procedures. I mean, I've already changed that capacitor on the sample and hold, and already it's a lot better. Okay, that's handy. Hello? Oh, hi! Can I borrow that screwdriver thing of yours, please, to do this? Thank you. Not exactly what I had in mind, thank you very much. There you go. That one. Yeah, I'll get it. No, I can get it. Okay. Not very sonic this, is it? Thanks a lot. Yes, I'll close your door. Anyway, right, let's get setting this thing up, shall we? Right, so unfortunately I didn't put on the video about me going through all the setting up procedures, because all the setting up procedures is page after page after page of turn this pot, do this, turn that pot, balance that, use the oscilloscope, do this, that and the other. And I thought this video is probably long enough already and you may be getting bored by now. I'm certainly getting bored of it. But the machine runs now, it makes a noise and it sounds very interesting, and I can't wait to get diving into it to see just what else it can do. I mean, I haven't touched any of the interface stuff. There's key CV out, VCO, CVs in, controller, pre-VCF signal, etc. There's a little bit of patching I can do here, and maybe, you know, use it with another source to play it. But anyway, thanks very much for watching, and I'll get all this put back together now and maybe just do a little demo right at the end. So all the best, thank you, and goodbye.